From number 1, an arithmetic sequence, that's important, arithmetic sequence satisfies the following conditions: A2 minus A6 plus A4 equals negative 14, A8 minus A7 minus 2A4 equals 0. The main idea here is to recall that each of these members of arithmetic sequence can be represented using the formula an equals a1 plus n minus 1d. So of course a1 and d are unknowns, so we need to solve for a1 and d, but we will represent all this information that's there in terms of a1 and d. So instead of a2, we'll write a1 plus d. So 2 equals 1 gives us this, minus a6 is a1 plus 5d according to this formula, and plus a1 plus 3d is negative 14. The same way here, it could be even easier. a1 minus a7 is just d, because that's two consecutive members, their difference is d, minus 2 times a1 plus 3d equals to 0. And that's it. This is now a system of two equations with two variables, and that should be fairly easy to solve. Combine like terms and all that, a1 and minus a1 gives us just a1. How many d's? D and 3d is 4d minus 5d would be a1 minus d is negative 14. Here again, minus 2a1 minus 5d is 0. Minus 2a1 minus 6d, and d is minus 5d. And then, right, so what do we do here? Then we solve this system. The easiest way I would say is just to eliminate a1, multiply this by 2 and add it up. So 2a1 minus 2a1, a1 disappears, minus 2d and minus 5d is minus 7d, minus 28 and 0 is minus 28. So from here we get d equals 4. Now when d is 4, from this equation, let's say a1 is d minus 14, which is 4 minus 14, which is negative 10. So here it is. That describes the arithmetic sequence. When you know first member and d, it's completely described. So it was just the easy application, I would say, of our standard problem. Let me squeeze number 2 here. We want actually to calculate S of 6,3, and then what would that be? If you remember, we first prepare S22 to be 1, and then S32 is what? The formula was S of n2 is 2 to the n minus 1, and we described why is that true. So this would be 2 to the square minus 1, so that would be 3. S4, 2 is 7. S5, 2 is 15. S6, 2 is 31. And if we don't need any here. Wow. All right, now our recursion formula goes Sn k equals Sn, and we explain also how to get it, k times Sn minus 1k. Here is when one member is his own team, this is if he's joining one of the other k teams. So generally what? Instead of going from S63, I suggest that we go from the bottom up, like you did on your quiz. So S33 is just 1. Then what? S43 reduce, it will be S32 plus 3 times S33. So that will be S32. We find it here, so it's 3 plus 3 times 1, and that should be 6. S5, 3 is the same way. S4, 2 plus 3S 4, 3 previous one. So generally what we really do all the time, we multiply the previous one and add the appropriate level, which is 7. So we get 25. So S63, without too much writing, we take the next one, which is 15, we triple the previous one, and we get 90, and that's the answer. All right, problem number 3. You see, calculations are not bad, and the ideas are, I would say, the standard ones. Usually in the class, I'm afraid when I erase something too quickly, but this is a video, so you can just rewind if you didn't pick up everything. So, here's the sequence, dk equals 2/3 dk minus 1, minus 1/9 dk minus 2. Conditions are d1 equals 9, d2 equals 6. And we want the explicit formula, standard thing, we do characteristic equation. What would that be? R squared equals 2/3 r minus 1/9. On the other side. And then what? You might be tempted here, actually, either use quadratic formula or use the factory, because of the fractions I would maybe suggest quadratic formula, which is minus b plus or minus square root of b squared minus 4ac over 2a. That's what r is. This is ABC. BC, so it would be b squared is 4/9 minus 4/9 over 2. This is 0, just happened, 2/3 over 2 is 1/3. We actually get the double solution. When we have double solution, then we have the formula that dk or dn, doesn't matter, dk is what 1/3 of the k times ak plus ck plus m, doesn't matter. That's how it is when we have double solution. And that's it. Now the only thing is to fix C and D according to the initial information. So we get what? D1, which is 9, equals 1/3 times C plus D. And then 6 is 1/9 times 2C plus D. And then the easiest way is just to get these numbers on the left and get a system. C plus D is 3/9, which is 1/3, and 2C plus D is 9/6. Or generally, to have a common denominator, let this be 2/6. If we subtract, we get that C is 7/6. When you subtract, these cancels, we get C is 7/6. No, I messed up something. Oops, my algebra was bad, sorry guys. It's really bad. So instead of, we multiply both sides, so we get 27 is C plus D, and here 54, no fractions. Now the same thing, when we subtract, we get C is 27, and then D is 0. So generally, the formula is 1/3 of the K times 27K. And then we can write that a little nicer. Yes, what would that be? You write K, then since this is 3 cubed, you cancel 3 of those, just a little fast, a little better. 1/3 to the K times 3 cubed times K. And then you cancel, you can write this 3 to the K minus 3 times 3 cubed, they cancel. So here's, either way, if you left it like this, it would be full credit. And then problem number 4, similar to this. So those are algorithmic problems, and just you need to learn those sections and then apply algorithms and be careful with calculation. Number 4, here is again AK equals AK minus 1 plus AK minus 2, and conditions are A0 equals 5, A1 equals 8. So this one will be a little more calculationally demanding. If you remember, we did that in our lecture. So this is Fibonacci sequence. We will change the initial conditions. So what would that be? The equation is R squared equals R plus 1. from here, r squared minus r minus 1 equals 0. So r equals 1 plus r minus square root of 5 over 2. And then in my notes, I call just for this, and I think in the lecture also, alpha is the one with a plus, and beta is the one with a minus. So our solution looks like this. Rk equals C and D, or C1 and C2, C1 and C2, C1 and alpha, yes, okay. So Rn, doesn't really matter, Rn is C1 alpha to the end plus C2 beta to the end. And the same reason, like in the lecture, I prefer alpha and beta because it's just simpler writing. So what would that be? When I plug in, no, this is not Rn, it's A. These are R's. Yeah. So A0, when I plug in 0, I get the following 5 equals C1 plus C2 because these are all to the 0. And then 8 equals C1 alpha plus C2 beta. Why? Because when I plug in n equals 1, I just get alpha and beta, and then A1 is whatever it said, it is 8. So generally I need to solve this system of equations. So what would I do? So the simplest way is just multiply top line with alpha. And then when I subtract, we get the following: 8 minus 5 alpha. C1's cancel because of our good move. C2 times beta minus alpha. So from here we get C2 equals 8 minus 5 alpha over beta minus alpha. And how much is C1? For C1, I will just use the version before I multiplied with alpha. So C1 is 5 minus C2. So it's 5 minus 8 minus 5 alpha over beta minus alpha. So here it is, we are done basically. Now we can just finish the calculation. What would that be? We plug it in, so it would be what? 8 minus 5 alpha is 5 plus 5 root 5 over 2. Beta minus alpha, when you subtract, then what happens? Ones cancel and you get just root 5. So beta minus alpha, beta minus alpha is actually negative root 5. Because ones and ones cancel, minus 2 root 5 over 2, that's minus root 5. So what would that be if I multiply by 2? On top, I get 2 times 8 is 16, minus 5 is 11, minus 5 root 5 over minus 2 root 5. And then what would C1 be? It would be 5 minus my C2, that I'll copy in this calculated form. What will that give me? Minus and minus will give me plus. So I get 2 root 5 here. And I get 10 root 5 minus 5 root 5 so it will get 11 plus 5 root 5. So here it is. Our solution is, and maybe I'll pull out this minus. So our solution will be AN equals C1, which is 11. So AN is C1, which is 11 plus 5 root 5 over 2 root 5 times alpha to the n times 1 plus root 5 over 2 to the n. And then C2, as I said, I'll pull out that minus 11 minus 5 root 5 over 2 root 5. 1 minus root 5 to the n. So here's the solution. And then, if you remember, in the lecture we kind of did a little polishing. Here really you don't need to do that. I think I asked you how much is A10. So A10, so what do? You just plug in this in calculator, so, and you will get 610. So nothing really fancy. I wrote 5 minus 11. Okay, I distributed this minus out there, doesn't matter, we got the same thing, yeah. So just using calculator, you fix the problem. All right, next question. Question number 5. It says a ball is dropped from the height of 20 feet. So here is the ground, here is 20 level. So ball is dropped down. And then it bounces up. And that bounce is, so if this is h, this is 0.72 h. And then it drops down for the same height. Whatever it drops, so this is going up, this is going down. And then when it hits again, it will be 72% of what it had down, but it bounces back the same distance. So generally what? So, find the total distance when it hits the ground for the 7th time. So this is first time, this is second time, this is third time, and then 7th time we also have up and down, so this is the 7th time. So what would that be? So the whole sum equals, first you just get 20, then you get what? 20 times 0.72, but times 2 because you have up and down. So 72% of what you have. Next time you have 72% of 72%, like in geometric progression, so you get 20 times 0.72 squared times 2. That's this one. 0.72 squared times 20. And so on. What's the last one? I check, do I have up and down on the last one? Yes, I do. The only dilemma, so I have doubling, I don't know which power it is. So let's say, when it's second time, it's this power is 1. When it's third time, power is 2. So without big formula, 7 times power will be 6. So what do we get then? I can keep, what can I do here actually? The easiest way, I don't know how I solved it, yeah. The way I solved it, since everybody is doubled and this guy is not, I will double that one and subtract 20. So it will be minus 20 plus, now everybody's doubled. So I'll pull out 2 times 20, so who's left? 1 plus 0.72 plus 0.72 to the 6th. So I subtracted and added 20 to establish that doubling pattern. And then what? This is 40 times, this is the formula, and it says what? Sum of Ri, where I goes 0 to n equals 1 minus r to the n plus 1 over 1 minus r. So this would be 1 minus 0.72 to the 7th over 1 minus 0.72. Right, and then when you plug in all this in a calculator, you get 108.53 feet. All right, that was problem number 5. Problem number 6. So A is 1, 2, 3, 4, 5. And the relation is x are y if x is a subset of y. It's relationship not among the elements, about subsets. Subsets of A. So first question is it reflexive? Is every set subset of X? The answer is yes. Every set is its own subset. Is it symmetric? No. Why? Because 1 is subset of 1, 2, but 1, 2 is not subset of 1. So that's a counterexample. Is it transitive? Yes. Why? Because if X is subset of Y and Y's, and Y is subset of Z, then X is subset of Z. I didn't prove it, but that's easy to prove using transitivity of implication. And that's it. So that was a very easy one. Problem number 7. Define the binary relation on the reals. So on reals, and the relation is AS, and members are related if their difference belongs to Z. So is it reflexive? So is it true that ASA, which is equivalent with A minus A, belongs to Z, with 0 belongs to Z, which is true, 0 is an integer? Yes. If A is B, that means that A minus B is integer. That means opposite of integer is integer, which means B minus A is an integer according to definition. That means B as A, symmetric. And then transitive, if we have A as B and B as C, we get what? We get that what? A minus B is an integer. And we get, like on your quiz, B minus C is integer. Then what do? We add them up. A minus, sum of two integers is an integer, and that means A as C. So it's transitive. And then at the end, I ask you to describe the equivalence class of root 3. So what would that be? Set of all real numbers, how did I call them? X from R, such that x minus root 3 equals m for some m in Z. That's exactly what it says. If so, those that are equivalent to root 3, that means those that have difference to be an integer. And then why did I write it like this? Because now it's solvable for x. So it says x equals m plus root 3 for some m in Z. And then instead of saying all the people that are basketball players, you say all the basketball players. So it says set of all m plus root 3 where m is in Z. So generally, who's there? Who is there? Root 3 itself, 1 plus root 3, 2 plus root 3, 3 plus root 3. They are all in the same class. Root 3 minus 1, and so on. All right. That was problem number 7. Problem number 8. That was the last problem. Your exam will have 10 problems. Last spring, for some reason, we had 11 problems. So here it is. Number 8 is the same one as your quiz. So that would be find the remainder of 7 to the 38 modulo 660. So what did we do? We generally wrote what? 38 in the binary, and that would be 32 plus 4 plus 2. And then we calculated powers using calculators, so 7 squared is congruent with 49. You remember how, no, 7 squared is 49, equals 49. And then 7 to the 4th is congruent with what? 49 squared modulo 660, and that's congruent with 421. You remember how we get that? We take 49 squared, divide by 621, then remove the quotient, not 621, sorry, 660, the quotient, and then that little decimal multiplied by 660, and you get remainder. That's it. All right, and then repeating that using calculator, you get 7 to the 8 is 361, 7 to the 60 is 301, 7 to the 32 is 181, and then what? 7 to the 38 will contain what? 7 to the 32, 7 to the 4th, and 7 to the square. So I multiply, so 7 to the 38 is congruent with 181 times 421 times 49. You put that in calculator, reduce 660, and you get 229. As I said, the same way that we did it in the exam, doing the lecture notes, or lecture videos and also what you had in your quiz number 12, that you probably, by the way, did really well. And then if I want, what is the inverse of 7? So if I want to solve 7x congruent with 1 modulo 660, we said the following. We said that we do Euclidean algorithm for 660 and 7. So we go 660 is 7 times 94 plus 2, but these are reserved numbers. And then 7 equals 3 times 2 reserved plus 1 reserved. And we need to get 1 because they're relatively prime, so from here we get what? 1 equals reserved. 7 minus 3 times 2, these are reserved, which is 7 minus 3 times. This 2 is 7 times 94, 660 minus 7. 660 minus 7 times 94, these are reserved. And no, not 94, 7 was reserved. I'm rushing this. So what would that be? Equals, it will, how many 7s? So I have 7 and then reserved. Plus 3 times 94 would be 282 7s. And minus 3 times 660. So we get what? 283 times 7 minus 3 times 660. And then what? This is irrelevant because it's 0 modulo 660, so we get what? 283 times 7 is congruent with 1 modulo 660, so the answer is x is 283. And that was our exam number 3 last year. Yours will have 10 problems, but distribution of problems will be fairly similar. Arithmetic sequence, geometric sequence, problems, word problems to set up into recurrence, then those algorithmic formulas for quadratics, and then relations will be distributed this way. The only difference is there will be partial order relations at the end. Those were not on the exam last time.